Okay, so we're going to talk about moments. And today I want to introduce the concept and make sure that you can calculate the basic sorts of moments that you need. And then in the next session, we're going to look at beam reactions and how moments apply to beam reactions. So the first question is, what is a moment? And it's effectively something that causes turning. So we need to think about things trying to turn. And that's why I've got this whiteboard, because it can turn. It's a pretty spectacular demonstration. Okay, so the question is, when I make this whiteboard turn, what are the key things with regarding it turning? So yeah, I can make it turn there. So if I was trying to measure that turn or quantify it somehow, what are the things that you'd want to be able to communicate to someone if they're going to get them to do it without having seen it? So ideas. Again? Radius. Radians. Oh, as in the angle that it turns through. Okay, so not what I actually thought about doing, but okay, so we could measure the angle it turns through. Okay, so if that's something that's of interest, that would be looking at it end on. So we've been pushing it, and we're going to knock myself out. The angle in here, we could measure in radians as to how much it actually turned. Yep, so we could certainly, that's a sort of a result of the moment, is that we get a turn which we can measure in radians or whatever we want to measure in, angles, but radians is cool. Greetings, gentlemen, how are we? Good to see a nice hat there, Karen. That's to hide something or to hide the lack of something? Hide the lack of something. Good night. Okay, so yeah, so when we turn it, it definitely ends up turning through an angle, which we could measure in radians, absolutely. What about if we, in terms of what we're actually doing to make it move, what are the things that force? Okay, so there's definitely a force. Okay, so absolutely, to make it turn, I have to apply a force. I have to push the thing to make it turn. Okay, no force, and it's not going to turn. So absolutely, a moment is dependent on a force. No doubt about that at all. Absolutely. Okay. And like Nathan said, we're going to measure that force in newtons. Yep. So if I want to tell someone, turn this board by applying a force of 10 newtons, I can do that. That makes sense. Okay, cool. What else do I have to tell them to figure out how to turn the board? If I wanted someone to duplicate that motion, what else do they need to know other than 10 newtons? Direction to push it? Absolutely. Okay, so direction is really important. And what are my options on direction? Okay. I'll just repeat this for the camera. I'm getting a bit of this. So pushing away from the board or into the board, is that what matters? Because if I turn it around again, I'm now pushing in quite a different direction from what I was pushing before, but I'm still getting the same sort of motion. So is it that matters, or do you want to have some other way of thinking about it? Clockwise and anti-clockwise is the normal way we measure direction when we're talking about moments. So we normally think about whether it's going to turn clockwise or anti-clockwise. It's definitely the way we normally think about direction when we're doing moments. Cool. Okay, so you can tell me how big a force I have to apply. So I have to apply a 10 Newton force, and you can tell me you want it to do it so that the board turns. That would be anti-clockwise, wouldn't it? So if I do this, a 10 Newton force going anti-clockwise, and I'm going to get that motion. Is that all I need? Size is the 10 newtons. Yeah. The size of the board. Let's say we've just got this board. Do I? You've told me 10 newtons. Is that all I need to know? Just 10 newtons? What's that? So yeah, let's assume that's all built into the board. So we're just trying to figure out how big a moment I'm producing, how big a moment I'm applying. So it's 10 newtons anti-clockwise all I need to know. That'll give us an idea of how much work is done. Again, all that mass, let's assume all that's built into the board. So all you can do is tell me what you want me to do. Have you given me all the instructions I need when you say push it 10 newtons and make it go in anti-clockwise direction? Is that all I need to know? Length of time? Yeah, let's go back to the radians and say that we... Yes, let's just assume it's going to keep going. I'm not worried about how far, which is why I sort of said this one was a bit of a red herring to some extent. So it's just, yeah. So there's something else. Is that all I need to know? 10 newtons to make it go anti-clockwise and we're done? Why not? Okay, here we go. 10 newtons anti-clockwise. Thing of beauty, wasn't it? Here we go, 10 newtons anti-clockwise. Okay, I'm actually pushing a lot harder than I was pushing before, and I'm getting very, very little motion, aren't I? So what makes the difference? Where I push it, okay? And specifically, what makes the difference? So I mean, so if I push here, I get exactly the same as if I push here. Yep, that makes no difference. So just where isn't the issue, it's specifically... Okay, so how far away from where it's pivoted? So distance from the pivot, okay? So the key thing is distance from the pivot. Yep? That's the key thing. So when you say, I want you to push it with 10 newtons, you want to tell me it's half a metre from the pivot. And then we'll know how much turning effect we get. So what units is this going to be in, the distance from the pivot? What units is that going to be in? Metres, awesome. Metres. So if we combine those things, what unit do you think moment's going to be measured in? Newton meters, exactly. Okay, so if we multiply newtons by meters, so a moment is measured in Newton meters. Okay, so we've got to ask how many newtons and how far away from the pivot those newtons are applied. And that gives us a unit of newtons times meters, or Newton meters. Okay, so let's shove this board out of the way now that we've finished with turning things. That makes sense. So if I push it at the bottom, I can do quite a small force and move it quite easily. So small force, largest distance, and I get quite a lot of turning. I'm going to push it up here. I have to push it a lot harder to get the same turning motion. So smaller force, so bigger force at a smaller distance. Yeah. So that's the idea of a moment.